Hello everyone and welcome back to Arctic Retro. In today's video I'm gonna take a further look at this IBM XT machine and see if I can build an expansion card for it. I want to build a XT IDE Lite adapter for it so that it's easier to run programs and test out stuff on it. As you can see, the machine is working. It has an original hard drive installed. However, that hard drive has a lot of bad blocks. Only 16 out of the 20 megabytes available. And as you can see now, after installing MS-DOS, there's only around 10 megabytes free. And that's not a lot. So in order to copy stuff and run floppy disk images, I made this cable. I made a video about this a while back ago. You might have seen it. I did some restoration work on it. And this is was a temporary cable solution for using a GoTech drive, so I don't want to use that anymore. But as always, for these old machines, someone has made something modern to work with them, and I got this here. It's the XT-CF Lite version 4.1. I think I said XT IDE, but yeah. This uses an CF memory card as a hard drive. And I got this as a kit, so I need to build it first. And yeah, it looks to be straightforward. However, the CF card port, it's surface mounted and has very narrow pins, so I think that's gonna be a little challenge. The machine you saw, it's IBM PS2 model 30, and I hope this is gonna fit and can be used. It's gonna fit definitely, but it's compatible with that machine and can be used there. So there's not a lot of components on this. There's a few chips and there's a ROM there and some resistors and capacitors. That's it. So let's just get started then. Solder in everything and then I'll test it later. It's Saturday afternoon, it's the 16th of November and the time is 15 now and it's already dark. The weather is good, it's around 2 degrees outside, no snow yet. Alright, so I like to buy these kits because for one it costs less than a completed card, and number two, I think it's fun to build something and solder, so yeah. I'm going to start with all the sockets first. Before I start soldering up these PCBs, I always wipe off the solder side with some IPA in case there's any grease or dirt or anything. No, there's nothing. So this looks like a nice PCB, and speaking about PCBs, if you need to have produced your own PCBs, then you can use my sponsor for this video, which is PCBWay. This video is sponsored by PCBWay, and I just want to thank them for a great cooperation and for their support. They make prototype PCBs of very good quality, and they also do 3D printing, and they actually helped me with printing this case for this beautiful 1581 floppy disk drive replica. And they also produced and provided me with this PCB for the 1581 floppy disk drive. Even if you don't design the PCBs yourself, you can visit PCBWay's shared project site, and here you can find a lot of ready-made designs which you can just order directly from their website. And right now they have started with the PCBWay 7th project design contest, where you can participate with your designs and win great prizes. So please check out PCBWay for all your hobbyist project needs. Alright, let's crack on soldering. There's nothing much to say here. Everything is labeled and marked very nicely, so there's no confusion. I don't need to follow any recipe or anything like that. When I solder in stuff like this, I like to use blue tack, or in this case white tack. Yeah, that's just a quick way to keep things in place. And I also like to use my PCB holder. I forgot that. It's this one, and I bought it quite cheaply on the local electronics shop here, actually. So you just fit the board, and it's spring loaded, and then you lock it into position with some screws, and then it stays there. And it's easy, you just turn it around. Yeah, so I just solder one component at a time so that I don't have too much to worry about at the same time and possibly forget something. It can happen. With new PCBs like this, in my experience, you never need any flux or anything. I mean, my solder tin has flux core or rosin core, so it works beautifully, and it's also leaded solder. Flows very easily. I usually just on sockets like this, I solder 2 of the corners. Then I push from the other side so that it gets really flush with the board. Yeah, that was actually needed there. Quite small holes on this. Sorry about the glare. It looks like I'm using a lot of solder by the length that goes into the soldering, but this is very thin solder wires. I have had this for several years, one roll, and it's been very good. But you need to feed a lot all the time. So the trick is to get the correct amount of solder so that it flows through the hole and through to the other side, but not too much. You don't want a big blob of solder on the other side. So that, I think, just comes with experience. Sometimes you use too much and you learn. Also clean your solder iron tip regularly. You know, you can see this is already quite black on the tip. So that was the first socket. That went well. Then the next, try to solder both these in one go. If you don't have blue tack, obviously you can use something else like tape or something. Alright then, I just finish off all the sockets and then I'll be back. That was the sockets, and I just clean a little bit in between. You know, the flux residue, it gets hard, and the faster you clean it off, the better it comes off. Of course, I'll clean it when I finished in some hot soapy water. Then we have a couple of components here that actually looks like chips, but they are dip switches. I guess the direction is this side here goes where the notch is. Alright, so it's starting to look finished. Just need the small components, solder those in. I'm not looking forward to this connector. I don't have a lot of experience with such soldering. So if you wanna watch that, then you just have to continue watching. Now these electrolyte capacitors, and that's not really the correct capacitors size-wise. I mean, it's the correct capacitance, but it doesn't really fit with the holes. But this works, but doesn't look very nice. And I'm also soldering in the resistor network. That is 8 resistors in one component, all with the same value. Snip off just above the solder, not through the solder, ideally. Then we have some regular resistors, gonna solder those in. Yeah, and these are not marked, so I need to check their values. I can't read the color codes without having some kind of lookup table, but it's much faster just to use the multimeter to measure it. So this is then 5.6K, and this one 328 ohms. So I start with those. To bend the leads, I just use this handy little lead bender tool that I 3D printed. You just position the component and bend the leads. So where is 5.6K? It's here, 5.6K. I mean, it was 328 and that's the 330, that's the standard value. Just pull and then bend a little bit on the back side. That was all the resistors. Now just soldering those in. Alright, the easy part of the soldering is complete, and yeah, it was very easy, no worries at all. Only thing I was a little bit unsure of was the LED, because the marking did not indicate the polarity, so I actually had to check the schematics to find out the polarity of the LED. I cleaned it up and it looks nice and shiny now, and yeah, still a little dirty there, but maybe. I'm just gonna double check, see if all the solder points are there and I didn't miss anything. This needs a little bit of planning. Obviously it's gonna be soldered in there, but as you can see, let me zoom in. This is a very fine pitched pins, but there are holes, guiding holes, so that makes it a lot easier. Don't need to manually try to position it correctly, but still there's a little bit of leeway. So yeah, I think I'll actually just solder the sides, these anchor points first, and then I try to solder this row of very thin pins. I hope I'm able to film this properly when I'm gonna do it. Always an issue to have the camera in the way when you're doing fine work like this. For this, for sure, I'm going to use some real flux. And since this is plastic also, try not to melt anything. So that's secured. Now I check if all the pins are correct. Seems like they need a little bit adjustment. Yes, I think that looks as straight as it can get. So just solder the other anchor point then. And now the difficult part. I cleaned my solder iron tip very well, and I'm gonna add a lot of flux here and then just put some solder onto the tip and then drag it down like this. I've seen this being done on numerous videos, however doing it yourself, it's yeah, something else. But if you have a lot of flux, then the solder should be flowing just over the metal, and hopefully not stick together and breach the pins. Okay, here goes nothing. Add the solder blob. No, that did not go well at all. Complete disaster. A lot of pins got breached together. So this might end up as a failure video. Still try to fix it. Maybe I'm using the wrong tip. Maybe I should have used the flat tip, but at least I'm gonna cover all the pins so they all get soldered to the board. Another issue is that the pins are so small that I can't hardly see them, even I'm using magnifying glasses, but clearly you can see there's some bridges all the way here and here. So I try to clean that up with lots of flux and yeah, just dragging the iron over it. I think it got a little bit better. Now I'm just gonna try and suck up some excess solder. It looks so easy on YouTube videos, but yeah, this is actually hard. Maybe it would have better to use some solder paste and then hot air. This is not looking promising. Everything is breached here, all the way from there to here. Oh my god. I think I managed to get away most of the solder by doing this. Problem is I might suck away the solder holding the actual pins to the board as well. But this seems to work. Seems like the plastic is quite heat tolerant, so it doesn't melt. Yes, I think that looks a lot better. I'm gonna try and clean it up so I can take a closer look. Let me just probe a few. No, this looks good. That's just the probes touching each other. Oh, these are bridged around here. Alright, so you see the struggle. I'm gonna do the rest of cam, see if I can clear up all those pins and see if they are good connected, and then I'll be back either with success or failure. Well, I can't tell you if this is success or not, but at least I can't see any bridges anymore, and the pins seems to be soldered down. However, some of these pins are shorted, but I think that is from the PCB, because I looked at the schematics and there are some of the pins that are connected together, probably ground pins. With my eyes I can't see any bridges anymore, but that doesn't mean there isn't. I mean, there could be under the contact. I think this last pin here is loose. Try to solder that. Yes, I think I'll go with that. If it doesn't work, then it doesn't work, and then the video is over, but I'll try with that. So a bunch of pins in the middle are still shorted, but according to the PCB layout here, you see all these pins are in fact shorted. This one, this one, this one, these two are shorted. This is shorted to that. This seems to be a big ground plane, and yeah, I'm not sure down here. It seems like a lot of the pins are not in use. And if we take a closer look at this picture here, I zoomed in real close. I can't see for sure that there is no shorts anymore, but for me it looks like there isn't. So I think this is ready to populate. However, I don't know if this EEPROM has been programmed or not. I actually need to check that out, because this card actually needs some firmware, and I just insert the EEPROM chip into my EEPROM burner here, and then I'm gonna read it, see if there's some contents. This is an Atmel 28C64. Let's read it then. Yes, this chip has content. It says here XTIDE 203, XTIDE Universal BIOS from 2013. So this is programmed then. Good. Yeah, all that remains then is to populate the chips, and yeah, they're also nicely marked, labeled on the board. This is a 7404, and this is a 7432, and those two are 74688. Alright, so that's completed, and now I just need to find a CF card, and then I need to figure out how to configure this. There are holes also here for securing the CF card slot even further. Yeah, I don't think I have those kind of small nuts. I think this is good enough. It's not like I'm gonna be pushing different cards in or out of this. Oops, I just noticed one pin poking out. That can easily happen if you're not careful. Just gonna fix that quickly. I found a 2 GB card. Not sure if that's too big or something, but yeah, gonna try with this. Yeah, I checked everything for shorts, and also checked all the connections on the ISA slot here to make sure there's no shorts, and there isn't. So just need to figure out how to configure this for this machine, and that's this one. Does it still work? Yes, I know it does. No, I must admit I don't know too much about PC architecture from that time, but I know about the ISA slot, and yeah, that it contains the data and address bus connected to the CPU, so that's what this card is actually utilizing then. The GitHub documentation isn't very good. It just has some tables about the dip switches settings, and doesn't really explain much. I think it assumes a lot of knowledge from before, and yeah, I don't have a lot of knowledge from before, so I just need to try my way out here. So if we assume that the I/O address selection is the default, which is 0x300, then these 3 switches should be up then, and the 4th switch is not in use. For this switch block of 8 switches, there's a lot of settings. The first one indicates EEPROM enable, and the second is EEPROM write enable. So I guess I want to enable the EEPROM, but not write enable it. And switch 3 is the EEPROM address selection, switch 3 through 7. I don't have a clue about that. I think I just set it to the first one, which is C0000, and that means all up to 1, except the last number 8. It doesn't mention switch 8, so probably not in use then. So I guess then just to insert the card and then just see what happens. So let's see if this goes in. It's usually very tight on these new cards. Alright then, let's turn it on and see what happens. I am aware of the risk that this card, if I did something wrong, might actually damage the computer, but I'm taking that risk. But it won't boot, so nothing happened here. Yeah, completely dead, nothing on the screen. Not good. I'll pull this out just to check if I managed to destroy the machine or not. No, it still boots, but it seems to have lost its date and time. So I changed some of the dip switches, but let's just check if there's any voltage to the board and the chips. No, there's 5 volts, alright, but there's no LED. I took out the CF card and inserted it in another slot, and now it actually, the machine boots and the LED is on. So I don't know if that's why I changed the slot or if it's because I took out the CF card. I'm going to try and put it down to the other slot again. No, it's the same in that slot. Now without the CF card it actually seems to at least not halt the computer. So I suspect there's something electrically wrong with this card now. So on the back side, here we have the plus 5 volts and grounds. These 2 outer pins are ground, they are connected. This is 5 volt and this is 5 volt, and those are connected too, but it's not shorted to ground. However, here on pin 10 and 13 there's a short, and I find that a little bit strange. As I said, I don't know too much about the ISO standard and the PC architecture behind it, but pin 10 it's ground and 13 is I/O write, I guess, and doesn't really make sense that they both are grounded. So is that something wrong I did? I need to check. Take a look at the schematics where those lines are going. And in fact, this I/O write goes directly to the CF card. It's here, I/O write, pin 35. So I need to find pin 35, see if it's shorted somehow. Yeah, right away this is seemingly connected to many of the pins on the CF card. Over here and then all the way over here. I'm not sure if that's correct or not. Anyway, it's unlikely that there's a short from all the way over here over to there, because there's no short in between. But obviously, since it's shorted to ground, and there's a lot of ground pins on the CF card, I think there's a short somewhere here. I was thinking about using some hot air just to see if I can get the solder flowing a little better and draw away from each other on the pins. I have a lot of flux there now, so maybe if I melt the solder it will fix itself. Try not to melt the contact. No, still have a ground problem. I mean a short from ground to that pin there, and so here we have IO right, that's the problem, shorted to ground. But pin 34 is IO read, it's not shorted to pin 35, and pin 36 is VCC, it's obviously not shorted to ground. I mean, if this pin was supposed to be grounded, it would be just connected to the ground plane. Instead, it now goes up here through this via there, and that via is under the switch block there. If I just knew if it's supposed to be grounded or not, it would be easier. According to the schematics, it's not. Try to take a look at the PCB layout, see how that trace actually goes. I wasn't expecting this to be a fault diagnosing session. So this is the PCB layout. It's mirrored compared to the actual board, but this pin here goes up here. It goes to a via that goes under the switch block near pin 2. And here it's pin 2, yeah, and that's that one, and that goes directly to pin 34. I mean 35. I'm mixing it up a little bit. So why is it grounded if the neighboring pins are not? I mean, the neighboring pin there goes to the ground plane, but it's not connected to anything. So I don't know the pin numbering on these CF card connectors, but seemingly it has ground pins on both sides. But that's not how it looks when you take a look at the schematics and see that pin 34 and 35 and 36 is not ground. So I have located the actual pin, but it doesn't look shorted to the neighboring pins. But it is shorted to ground, obviously. I'm gonna desolder this switch block, see if something happened under there, or it might be solder drawn under the contact itself. In that case, I will need to desolder the contact. I don't look forward to that. Anyway, that was enough for this analysis. I'll continue with this without filming, and if I reach a conclusion, then I'll be back. Alright, so I actually desoldered the whole contact for the CF card, and it was a pain to get off, in fact, and in the process I actually lifted 2 of the pads. Yeah, so this went into disaster, but those lifted pads, I can't see that they are in use anywhere, so I think it's okay now. I think my fault here was that I used that thin pointy solder iron tip. So I changed to this flat type and resoldered it again, and it seems to be much better now. Still used a little bit of braid to remove some excess solder. The card seems to be working. Depending on how I set the switches, I now got a ROM error message on the machine, so I'm not really sure, but I talked to my friend Koiro, and he apparently thinks that the ROM needs to be specifically programmed to be used with this card, even if there is a ROM write enable here. I'm going to take a look at that, see how this actually needs to be set up, and see if it actually does work. So I'll be back when I figure out that. Alright, I actually decided to show you what I'm trying to do here. I went to XTIDE universalbios.org, and here you can download pre-built binaries. Obviously the seller had programmed the EEPROM, but he doesn't know what kind of machine I have. And here is, in fact, IDE PS2, which is the machine I have. There's actually two, PS2 and PS2L. The EEPROM I have is only 8K, so this one is 8.3K, so that's too big. So actually try this one first. And if that doesn't work, you can manually configure and adapt a universal version of the BIOS. Obviously you need an EEPROM programmer like this to program a new version. I'm using the same chip. This is an EEPROM. It's an electrical erasable EEPROM, so it can be reprogrammed. So I have the correct chip selected now, and now I just load that binary that I downloaded. Program. Yeah, that succeeded. Just program it a couple of times more, just so that it gets properly programmed. Now the issue is, how do I know which address it actually uses now, or is that standardized? Koiro sent me a picture of his exact the same card, which is working, and he had it set like this. So now this is set for IO address 300 and BIOS address D8000. I'm simply gonna test that. I have disconnected the original hard drive, and then to be able to boot into the machine, I connected the GoTech. Just gonna boot into DOS and see if we see anything with F-disk. Yeah, and apparently that doesn't work. It actually says now D8000 ROM error. Let's see what happens if we just continue. F-disk. No fixed disk present. Okay, so that didn't work. I actually decided to take the general XT version of the BIOS and modified it, and to do that you need to use a command called xtide config. It has to run from DOS, and in Windows it can't run because it's not compatible, so you need to use the DOS box. So now I have put the files on drive on my C disk, mount C, xtide, C. Yeah, there's the three files and the xtideconfig.com. Yeah, so I just need to figure out how to use this load BIOS from file, and we're gonna use this one. Press enter to close dialog. Configure. Yeah, I just need to figure out this before I continue. I'll be back. Yes, I'm back. There's several settings you can do to configure this. I'm just gonna leave everything as default. So the primary IDE controller and everything. Boot settings. I saw somewhere here it was set to 300. Yeah, there it is. Device type XTCF PIO and base address 300. That's correct. And then we just flash the EEPROM, and that means modifying the binary file that we have loaded. So I'll set as Koiro did D8000. Okay, start flashing. So now it was written successfully, and then we can take that file and burn that. No, then it just rebooted. I think that was not correct. I think you just need to save it. Save BIOS. How do I set the correct... Alright, now something happened. So I actually skipped the recording for a while because I had to dig around here, and yes, I actually decided to just use the smallest BIOS, the one called XTIDE, and I used that configuration tool, and I saw that it defaulted to address D000 and 300, and I set that, and then I burnt the BIOS, and yeah, it actually detected it. It says here XTIDE Universal BIOS, and it actually prints the name of the memory card correctly. It's a SanDisk, but it can't boot because obviously it's not formatted. So I don't know how to, if I can disable this some way. FDDA, yeah, okay. But how do I continue? So in order to not boot from the C drive, which is not formatted, you need to press A immediately when you see this message, and now it's starting booting from the GoTech. And look at that, now actually MS-DOS setup detected that there is a hard disk. So instead of fiddling with F-disk, setting up partitions and stuff like that, I think I'll just try to install MS-DOS right away. Yeah, now the LED flashes on the card. Yes, this actually seems to be working. Just change to Norway and keyboard Norway, because that's what I have. So I'm actually happy this worked now. Yeah, I was a little bit depressed yesterday because I thought all the soldering and everything, and I ripped a couple of pads. So I actually went ahead and ordered 2 more of these XT CF card PCBs and CF card connector, but seems like I didn't have to do that after all. But it was quite cheap without the components, obviously. So alright, so MS-DOS successfully installed, but still it won't boot from C. So actually wondering if the partition is actually set active. I don't know what MS-DOS did when it created the partition, if it used the maximum space or something else. So yeah, I just need to boot into DOS via floppy again and check out F-disk. Okay, so let's see the partition info. Yeah, it's actually allocated 2 gigabytes. I think that's the max of FAT16. So set active partition. Let's try that then. The only startable partition on drive 1 is already set active. I actually haven't formatted it because EOS Digital, the volume label, I took this CF card from a digital camera, and it's a Canon EOS. So what if I go to C:, and take a directory? Yeah, it hasn't formatted. The DSIM directory is from the camera. But we have access to the disk, but it won't boot. So maybe it's better I make a new partition and actually format the card. Yeah, I'll do that. It's just a matter of using fdisk command and delete the partition and create a new one and format it. So I'll be back after that. Okay, I did repartition the memory card, and I formatted a new partition of 500 megabytes, but still it wouldn't boot. So I got a tip that you need to run fdisk/mbr on the partition, the active partition. You want to set the boot master record, and that worked. Let's check it out. Yo, it's booting from C, starting MS-DOS. So on these kinds of old machines, it's actually recommended to have smaller partitions. If you have a full 2 gigabyte partition, which is the maximum for MS-DOS 6, you actually will have to wait quite some time when you type the dir command, not actually directory listing, but for it to calculate the available space and things like that. So even this 500 megabyte partition takes a few seconds. Just want to format the D now. Yes, the formatting actually went pretty fast compared to the original disk, where it took several hours. As you can see now, this is 1.5 gigabyte and it's already 20%. Give it a label, data. I don't have a memory card reader for CF cards, but I have another computer with built-in CF card reader, so I'm gonna use that. So I was curious to know what happened if you connect the original hard drive, and I actually did, and I took out the memory card, and now you can see it didn't find any master or slave, but it actually booted then from the old original hard drive, so it's still available. Oh yes, I always load the flight simulator on the PC, the more modern PC. I have a Flight Simulator 2020, which I use from time to time even now. So this is Flight Simulator 2.1. So I have a color monitor. Yeah, I'm not gonna try and learn how to play this now. Let's just run demo mode. It's not displaying any color. But still cool to be able to run this old stuff now. Now compared to the modern days Flight Simulator 2020, this is something else, but I suppose it was kind of realistic anyway. You know, you see it's some kind of early 3D graphics. Since I reconnected the original hard drive, it's actually booting from that. Now I'm not sure how I can get it to boot from the memory card in this case, but that doesn't really matter. I'm gonna disconnect it anyway. You can access the memory card using D:. Oh yes, a little Rambo from 1985. I wonder how this is gonna look. Oh, I think it's just an adventure game. Yeah, you see the log. You can't take the log, okay. All right, this is cool. This is Saxon. Yeah, it's hard without the joystick. But yeah, it looks and feels like Saxon. Oops. Yeah, I think that's enough with the games on this machine. I've proven it works with a memory card, a CF card, and that was my goal. Now I have this PC if I wanna test some old stuff. Only thing now that remains, I'm printing a slot cover now, so that's the only thing more I'm gonna do. Yeah, this is the bracket. It came out quite nice. I think it fits. It's gonna be like this then. I just use a couple of plastic standoffs here because the card is dangling in the air. But with these standoffs, it's supported below. But I'm not gonna screw it down to the motherboard or anything. It's not possible. Yeah, these holes are too little, so I'm gonna extend them a little bit. Couple of small plastic nuts. That looks nice. The hole could have been quite a bit smaller, but yeah. Now, unfortunately, it doesn't fit quite. If I push in the card in the card slot, then this one is too short, and if I try to press it, then the card comes out, so it needs some adjustment. But I mean, I can just cut off this part here, no issue. I don't need to screw it down. I can of course modify the 3D model. Sometimes we just need to do some easy mods. Oh, that went bang. It's not like this machine is going to be thrown around or transported or anything, so. Yeah, now it's fine. And the original bracket, I just keep it here. I taped it down there so it's not gonna get lost. Bruce Lee, it plays kind of fast, but yeah, it's fun. Okay, that was it for this video. I've done enough for now with this machine, the IBM PS2 Model 30. If you have any suggestions for other upgrades I can do, then please write them in the comments. I just want to say thanks for watching. Hope you enjoyed the video, and special thanks to my patrons, subscribers and members. See you next time. Bye bye.